welcome to my YouTube channel. Today we will be solving IPO, and this is a question under heaps. So let's read the question together. Suppose Leetcode will start its IPO soon. In order to sell a good price of its shares to venture capital, Leetcode would like to work on some projects to increase its capital before the IPO. Since it has limited resources, it can only finish at most K distinct projects before the IPO. Help LeetCode design the best way to maximize its total capital after finishing at most K distinct projects. It then says you are giving N projects where the ith project has a pure profit I, and the minimum capital of capital I is needed to start it. Initially, you have W capital. When you finish a project, you will obtain its pure profit, and the profit will be added to your total capital. Pick a list of at most K distinct projects from the given projects to maximize your final capital and return the maximized capital. The answer is guaranteed to fit a 32-bit signed integer. Fun fact about this question, I interviewed for like an internship at Jane Street, and this question was similar to what they asked me. It wasn't the same thing, but it was very very similar. So this question, I think the most hard part of it is actually just understanding the question itself. I think when you can understand the question, it's not as hard to solve the problem. Okay, so I think what we're going to do, let's first simplify this problem. Okay, W. So that is the initial capital. And then we then have a number of projects which Leetcode can invest in. So that number of projects is called K. So the number of projects Leetcode can invest in for investments. Okay? Now, for investments. Yeah, you get it. So now we have a list of projects. So in the question, we see that we have W initial capital. Then we have a list of projects. We have a list of can only finish at most K distinct projects before the IPO. So we want to help. So we have a list of potential projects, and the potential projects include each capital. So we have an array of capital, right? So we have an array of capital which we can use to invest, and then we have a list of profits. So the profits that Leetcode wants to make from its investments. This problem also, you have to understand how I think finances work, like to really get this problem. So what we want to do is that Leetcode can only invest in projects that they can afford. So you don't want to put your money in something that you can't afford and then run into debt. So what you want to do is, after they complete a project, so let's say that Leetcode invests in a particular project and they complete the project, they want to get profits. So after they complete a project, the total capital will increase by the profit amount. And so we want to pick projects that can maximize their capital. So that's the problem. When looking at the solution to this problem, a naive approach would be to traverse every value of capital, right? Of the capital array based on the available capital. If the current capital is less than or equal to the capital value in the array, then we'll just store the profit value in a new array. Okay, but whenever the current capital becomes less than the capital value in the array, we have to select the project with the largest profit value. So the major thing is to get the project with the largest profit value, and the selected project value will be added to various capitals. So we have to repeat this process until we get the required number of projects. So this time complexity of the solution that I just spoke about would be a O of n square. And this is because we would need O of n time to traverse it. But I'm going to work on the optimized approach here. So in the optimized approach, what we're going to do is we are going to use min and a min and max heap. So we're going to have to use two heaps. So we're going to use a min and max heap to solve this. And what we're going to do is we are going to push all capital values into a min heap. Okay, so we're going to push all capital values into a min heap, and then what we're going to do is we are going to select projects that can be invested in the range of the current capital. So remember, Leetcode does not want to be in debt, so it has to be in their current capital. So we are going to select projects. We're going to select projects that can be invested in the range of their current capital. And then what we're going to do next is we want a situation where we're pushing the profits into a max heap, and I'll tell you why soon, because we're going to be comparing the values to be able to choose the maximum profit they can get. So we're going to select the project. We're going to push their profits inside a max heap. And if you don't know what a min heap or a max heap is, I read a file in my last YouTube video, so in the introductory video for heaps, I read a file from educative.io which explained it very well, so you can go through it with me. So we're pushing their profits inside a max heap, and then we are adding the profits. So we are adding the profits from the selected projects to the current capital. So we're going to keep doing this until we're finished selecting K projects. Okay. I'm going to start creating this. Before I start creating this, by the way, I got this solution from educative.io, so I'm going to show you the diagram so you understand exactly how it works. Okay, so generating min heap for capitals. So these are our capitals. We have 1, 2, 3, 2, 2, 3, and then our profits that we could have is 2, 4, 6, 8. Now, what we want to do is we want to go over it and create a min heap with all of the capitals. So we have 1, we kept 1 here. Remember, in a min heap, the parent node is less than the child node, right? So let's continue. So in a min heap, we have 1 here, we have 2 and 2, then we added 3 here. So notice that the parent node is always less than the child node, and we are appending our capitals. Then we have, so to generate the max heap for profit, so we are going to be using the 2 heaps to check, what is the highest profit that I can get with a capital. Okay, so pop the capitals from the min heap where the current capital is greater than or equal to the capital requirements of the projects, and push their profits in the max heap. So look, now we have the current capital is 1, the profit is greater than the capital, so we pushed 2 into it. Now let's continue. The current capital is 2, the profit, right, is greater than the capital. Like if we add it together, 1 plus 2, 4 is still greater than it, so we now kept 4 instead. Okay, now the current capital, let's see, the current capital, we have 2 here, but the profit is 6, so we kept 6. The current capital is actually 3. Sorry, I'm trying to also understand how it works. Let's look at the solution together. So this approach optimizes the selection of projects to maximize capital using the 2 heap method. So by pushing project capital into the min heap, projects are organized in ascending order of capital needed. So we're using a min heap which will fit within our available capital, and we're prioritizing those with lower cost. So we want to get the ones with lower cost. The selected projects are evaluated for their profitability by inserting their profits into a max heap. Okay. This allows prioritizing projects based on their potential return on investment. So we want to prioritize the project based on the highest capital, the highest profits at the lowest capital, if I'm correct. So selected project is excluded from the list of available projects, and the same steps are repeated. Okay, so let's see what's going to happen here. So we kept 6 inside here. Ooh, notice something, right? We are popping from our min heap as we go. So we have capitals capitals 1. We put into the min heap, we append 2, we append 2, we append 3. Now, when it comes to generating the max heap, we're using the min heap to generate the max heap. So let's look at it together. So our current capital is at 1, and then we keep 2 there. Notice something, we pop out that 1 and we keep 2 there. So we're using the min heap to check whether our max heap is generating the most capital. It's generating the most profits for Leetcode. So let's continue. So we have 2 and 4. So we're going to append 4 to that. Then let's continue. Remember, we popped that 1, 2 here. So we have 2 and 6. Let's see what's going to happen now. So we're going to put 6. We kept 6 there. We removed 2. Now we have 3 and 8. So our current capital is at 3. We appended 8, and now 8 is going to be the value with the most profits that Leetcode can make. Okay, so since we have selected K2 projects, our algorithm now terminates here. The solution right now, I want to increment the size of this. Okay, so first of all, we know our values. So we know that our current capital is equal to W, and our capital, we're going to have 2 heaps. So like I mentioned before, we'll have a capitals min heap, which is going to be an array initially, but you see that it has like a tree structure, because we're trying to get the values based on the least amount of capital. So at least that's what the min heap can help with. So we now have our profits max heap, which is also going to be a heap. And then what we're going to do, I'm going to need to import a heap here, but I don't think I need to. I think Leetcode already has the built-in functions already imported for me. So let's say, so for x in range, we're looping through the capitals array. So for x in range, learn capitals. What we're going to do is we are going to push it into our heap. So we're going to say heap push capitals min heap, and then we're going to put it into a heap, our min heap, and then the values of the capital. So capital X, X. Okay, now another thing we're going to do is we're going to say for this in range K, we are going to say that while capitals min heap and capitals min heap, the first value, right, is less than the current capital, we are going to pop it from our min heap, like what the diagram was doing. So C comma I, wait, it's not C, sorry. And also I'll show you something else I do to understand, because this problem to me, I don't know about you, but this problem to me was very, very technical. So I might use AI to understand how it works. Okay. So I might end up using AI to understand how it works. So I'm going to say while capitals, like some syntax that maybe I don't understand, we might still use AI to help understand it. So while capitals min heap and capitals min heap 0 0 is less than or equal to current capital, we are going to say C W comma I. We're going to pop it from the heap pop capital min heap, and then we are going to push into the heap our profits max heap and each and the profits attached to it. So the profits attached to it. So if you remember the diagram, we're just replicating it in code basically. Heap push, not pop, because we're appending to the heap. So we're going to append profits max heap comma profits I, and then if it's not profits max heap, we are going to break. Then J is equal to, sorry, I want to make sure I'm getting everything well. Not capitals, it's capital. Okay. Minus heap pop profits heap. So we're going to assign our current capital. Capital is then going to be current capital plus J, and then we're going to return our current capital. I'm going to delete these comments for now. Let's try. First of all, let me reduce this a bit so I can see. So let's try running it. Okay, capitals, oh yes, so it's meant to be capital. Let's run that again. Okay, so our solution was accepted, and let's try submitting it. So it was accepted. Let's talk about the time and space complexity. So remember I mentioned a optimized approach and a naive approach. The naive approach, the time complexity was more, I believe it was O of n squared. The time complexity of this is O n log n, right? Where n represents the number of projects, and the time complexity So the time complexity to select the project with the maximum profits from heaps are OK log n, where k represents the number of selected projects. So therefore, the total time complexity is O n log n plus k log n, which is going to be, altogether, it's going to be O n log n. The space complexity is O of n. This is because we're using two heaps, one to store capitals, one to store profits. So in the worst case, we meet the capital requirement of all projects right from the start, and we populate both heaps with n elements each. So I'll put it in the comment section too. So something else I wanted to show you was how so let's say that I look at a solution, I don't really understand some parts of it, but I grasp some parts. Another thing I do is I post it in like one AI platform or the other, and I ask it to break it down to me and explain each section. This is so that I can understand the solution. And in an interview setting where I cannot use external resources, I can easily know it because I have thoroughly studied it previously.